Welcome to this video on the fundamental theorem of calculus. Want to know the weight of this crazy Lego statue? You could weigh every single brick one by one, or you could use the secret calculus hides from you. Think of tiny one-by-one bricks stacking up to form a curve. As they stack, the area under the curve is the total area for calculation. Think of this statue as an accumulation. In math, every brick added is a tiny sliver of area. We call this process integration. This is the fundamental theorem. The area is just the difference in the antiderivative. It turns a messy pile of bricks into a simple subtraction. Stop counting bricks and start using the bridge. Subscribe to WaveEduAi to ace your Class 12 boards and JEE. Now let's look at how to apply this theorem by solving an equation. We need the area under this curve from x equals 1 to x equals 3. Don't be intimidated by the integral sign. It's just a fancy way of asking for the total weight. First, we set up the definite integral for our function. Now we find our antiderivative or weight function using the power rule. We get f of x equals x cubed plus x squared. This is our master key. Now for the magic. We only care about where we finished minus where we started. F of 3 minus f of 1. We substitute the values into the antiderivative. After calculating, we find the result is 34 square units. That's the fundamental theorem of calculus in action. Now let's look at how to apply this theorem by solving an MCQ trap. One of the most common traps examiners use for the fundamental theorem of calculus, FTC, involves the chain rule, specifically when the upper limit of the integral is not just x, but a function like x squared or sine x. Students often forget to multiply by the derivative of that upper limit. Here is a quiz to help you master this specific trick. Keep practicing, and I'll see you in the next lesson at WaveEduAi.